Good.
All right, here we go. There's 4 videos. They go for a while. So just sit back and enjoy. Hopefully the quality is good enough to play. And can I also say that at the end of the show, we'll pause for a minute. Any questions? And then we'll go on to the next video. The first one is I'm going to show you something that Michael and I picked up over the last week, and it's Mars 2020 Perseverance rover, July 2020. It's going to land. It's going to take off Mars, but also it's going to carry what they call the Mars helicopter, which is in the bottom picture, the bottom left-hand corner picture. Now, there's the rover. That's the actual rover just before they folded the thing up. And here is a sort of a diagram of this helicopter flying around. It turns out it'll only fly for about 90 seconds, but it has got solar panels, which allows it to recharge itself and continue the mission. And this is what it looks like. Solar panels, communication antenna, the rotor blades, propulsion motors. This thing is so light, it bears belief. It's about two kilos worth or something, some ridiculous figure. You'll hear that in the video. This is how the rover will actually land on Mars. It's got the sky crane. That'll be something to see, and pretty amazing feat of engineering. But you might see my mouse on the bottom. You don't see it in this picture. The helicopter will be stored. Now, I haven't been able to figure out how it's deployed. I've tried to listen and look at a few articles and stuff, but it's not clear. But apparently before the rover hits the ground, they'll release the helicopter. Presumably, it'll fly down, land, and then when the rover lands, clearly they're going to take pictures of each other. So
it looks like there's a panel underneath it, which you didn't see on the rover in the laboratory. You know, that whole white area at the bottom, it looks like it's an extra.
No, that's not real, and I'll show you why in a minute. That's what the actual helicopter looks like. It's sitting on a pedestal, but it's lightweight. Now, there it is on the underside. So you know that white flat bit you were saying, Michael? That's the rover. That's the helicopter being straddled to the rover, the base of the rover. That rover is upside down in this picture.
Oh, okay.
And I'm on board as well, so that'll be good. Looking forward to the flight. Maybe I'll get a one-way ticket one day. Who knows? And here's the video, guys. Enjoy it. Okay, that was one video.
So has it got automated navigation, or what? How does it know where to go and not to crash into something, where to land?
It's probably pretty automated. I don't know a lot about it at this point, but you can't afford what is it? I think it's 8 minutes there, 8 minutes back. So you can't control this in real time. the landings are so precise because of where it's landing that it has to be all automated. It's got ground terrain measuring software so that it will actually land pinpoint. So I suspect the little rover also has some capability. That was the first video. That just showed you what it was going to do. But here is the explanation of this helicopter.
We've got a feline viewer.
Oh, by the way, how did that go?
Yeah, it was all right. It was a bit jerky, but the audio was smooth.
All right, here we go. Let's go to the next one.
I'm at the Jet Propulsion Laboratory in Pasadena, and I'm here to see the first drone that's gonna fly on another planet. It's the Mars helicopter. Come on.
So, this is our baby.
No way.
Yeah.
That thing right there is the actual machine that is going to take off and land on Mars. It's going with the Mars 2020 mission. That is the Mars helicopter.
This will be the first powered flight in another planet.
I mean, this is that. Now, it's necessary to say first powered flight because in 1985, the Soviet Vega missions deployed 2 helium balloons on Venus. They transmitted data for over 46 hours while floating at an altitude of 54 kilometers in Venus's dense atmosphere, which at the surface has a pressure of over 90 Earth atmospheres. In contrast, Mars has very little atmosphere, only around 1% of Earth's.
Flying this kind of helicopter is equivalent to flying a similar helicopter on Earth at 100,000 feet. So you don't hear about many helicopters at 100,000. I think 40,000 feet is probably the record.
I checked. 40,000 feet is the record altitude reached by helicopters on Earth. 85,000 feet is the highest a plane has ever flown. On Mars, the air is even thinner than that.
Right, in terms of density, is 1% of what you have in this room. So in this room, a cubic meter of air is about a kilogram.
Yeah.
The same cubic meter on Mars will be about 15 grams to 18 grams. So that's
you have to push a lot of air down.
Yes, you gotta get a lot of air flowing, and so the obvious trick, if you will, is to spin the blades faster.
It can spin between 2,300 RPM and 2,900 RPM.
That is fast.
That is fast, yes.
2,300. Here I'm trying to work out exactly how fast that is. So I looked it up, and on Earth, helicopters typically spin their rotors at around 500 RPM. So the Mars helicopter will have to spin its blades 5 times faster.
But there are some limits. You know, we really don't want to get the tips of the blades breaking the speed of sound.
Because then you have shockwaves and all
and you get all kinds of funky aerodynamics and, transonic flows and things like that. So you don't want to go there. So we, in our designs, keep the tip mark numbers down to below about 0.7.
So 70% the speed of sound.
Yeah, so it's very conservative.
One advantage of flying on Mars is that gravity is only 38% of what it is on Earth. Even so, making the craft lightweight was essential.
Keeping the mass of this vehicle contained during the entire design process has been the major challenge.
Every single part had to be considered. The entire vehicle is less than 1.8 kilograms.
Whoa.
So less than 4 pounds.
That's about the same as this laptop.
The blades are foam core with carbon fiber layup. Each of them is about 35 grams.
Wow.
Yes, it's quite light, yes.
35 grams is the mass of 6 quarters. Think about that. 2 35-gram blades lifting an 1,800-gram helicopter by spinning 40 times per second in just 1% of Earth's atmosphere. How long can it fly for?
It's designed to fly up to 90 seconds.
A minute and a half of flight.
Yes.
To me, that sounds like forever. When you're talking about another planet flying autonomously by itself in 1/100th Earth's atmosphere, I mean, come on. That's a long time.
It is, yeah.
One of the questions I had was, why didn't they use a quadcopter design? Well, because on Mars, the blades have to be so long that the whole craft would barely fit on the rover. 2 counter-rotating propellers provide the simplest design. They also generate lift more efficiently when stacked on top of each other.
The bottom rotor sees the more compactified flow. The top one pulls it, the bottom one sees sort of a more concentrated flow. Right. So the bottom rotor actually can do better than if they were separated apart.
But how do you test a helicopter designed for conditions on Mars on Earth? What would happen if you just took your Mars helicopter and you tried to take off on Earth?
It would just make a lot of noise.
Really?
And it probably wouldn't get to full head speed either.
Because of how much atmosphere we've got.
Exactly. It's like trying to swim in a thick soup. We have a really amazing chamber here on lab called the 25-foot space simulator. And in that chamber, you could simulate any kind of atmosphere you want. You can go to Martian pressures, you can stay at Earth pressures, whatever you want. But that only took care of half of the problem. That was the aerodynamics aspect of it. There's the other part, which is the gravity. We needed a way to fake Mars gravity here on Earth, and the best way that we could figure out to do that was a gravity offload.
Gravity offload just means pulling up on the helicopter, so it only has to support about 38% of its weight, just like it will have to do on Mars.
And effectively, it was a high-tech fishing reel. So taking a brush DC motor, a reaction torque sensor, and a pulley, mounting that a couple stories in the air, and then attaching a fishing string to the top of the helicopter that would tug the necessary force required to offload the differences in gravity.
An actual fishing line?
Yeah, real fishing line.
But isn't that stretchy? Like, don't you want something that's perfectly rigid so as soon as you apply the torque, it gets applied to the craft?
Right. And we did a lot of testing with different vendors to find out which fishing line had the best spring constant for us.
What does the helicopter sound like? I imagined that in 1% of Earth's atmosphere, the helicopter would be pretty quiet.
Yeah, you're still at 1%, but it's still real loud.
Really?
Yeah, we have audio recordings of it too. But it's I would characterize it more like bang, something like that. When the gravity offload system was working and the chamber was pumped down, the helicopter thought it was on Mars. It felt like it was on Mars, the helicopter.
How do you actually steer this thing around and drive it?
So the way helicopters work is they have something called collective and cyclic. So what collectives do is they change the pitch on the blades uniformly. So throughout the entire revolution, you remove the collective, the blades will
change their angle of
change
attack.
the angle of attack, you'll get more lift. So that's basically what provides you heave control, right? You pitch more, you go up, pitch less, you come down. But then there's something called a cyclic on helicopters, which basically what it does is it modulates the pitch as it goes around. So it can pitch a little bit more here, less here. So it kind of like modulates. So what that does is it provides an asymmetric torque, right? When you're pitched up there, you get that additional torque. Now you get it, depending upon the stiffness of the system, you actually get it with that gyroscopic lag that can happen afterwards. So once you get an asymmetric torque, the vehicle wants to start pitching or rolling, right? So once it pitches and rolls, you're doing it stably, you are now pointed in a direction and your thrust vector now has a component that's horizontal in the direction that you pitched, right? So then you start translating in that direction.
I've heard that initially someone tried to fly it with a joystick?
Yes.
An early prototype?
If you were sitting right there on Mars and you were trying to joystick it, what is it like? And it's almost unflyable. And the reason for that, it's the aerodynamics of when you want to command a roll to the left, because you see yourself starting to move to the right, and you start commanding a roll to the left, there's a delay aspect. So that delay effect makes it very, very difficult for a human to try and pilot it.
You can't fly this from Earth.
Because of the 20-minute kind of time delay, so you have to really send sequences.
So essentially, you're going to push a button, and like 20 minutes later, it'll take off and do its thing, and then
Right.
you'll find out.
The way this flies autonomously, it has onboard gyros, onboard accelerometers, and onboard camera, an altimeter, and an inclinometer. And so using that sensor suite, real-time measurement, against the terrain and, of course, the gyros and the accelerometers sensing on board, the real-time estimation of the state of the vehicle is made continuously, again, hundreds of hertz. And then that's fed into the closed-loop control algorithm that takes the estimated state and then generates the correction that's needed at the blade level, and then the blades are continuously being controlled. So when you see video tapes of our successful flights, right, and the vehicle looks dead calm, is coming up and hovering and going laterally, coming back, the machines are working very, very fast and very, very hard. It just looks very calm, but yeah, so the blades are being controlled.
That is amazing.
Yeah.
How will it handle a gentle breeze?
A lot of the movies depict
Dust storms?
the big dust storms as being very aggressive on Mars. The truth of the matter is at 1% Earth's atmosphere, there's very little matter actually hitting you. Always,
I mean, you're using that to lift yourself.
Exactly.
So obviously...
So there's enough to lift, right? But we also need to spin at 2,200 RPMs to be in the ballpark of lifting ourselves.
We built our own wind tunnel that we put inside this 25-foot chamber. How many fans was it, Teddy? 960 computer fans. So, but it did sound like a jet engine taking off. So we built a fan wall array. It's called an open cross-section wind tunnel, where you don't need the walls. Just the fact of having an array of fans, we are very confident of it being able to go at 11 meters per second. Even this vehicle, if I had known that somewhere along the way I'd be building a wind tunnel to do this, I would have probably not taken the job on, right?
How long does it take to recharge?
We recharge the whole day. So the whole day at Mars.
Right.
So,
but does that mean that you could do one flight a day kind of thing, in theory?
In theory, yes. By design, it can.
What is the size of the battery?
Between 35 and 40 watt hours total.
That's equivalent to just 3 smartphone batteries. And get this, most of that energy isn't even used for flying.
It has to survive temperatures as low as about -80 to -100 degrees C at night. So we keep the batteries warm, and we surround the batteries with our electronics board, so the electronics boards also stay warm. We take approximately 2/3 of energy just keeping things warm and warming things up to operate. Only 1/3 of the energy is available for flight.
Do you have insulation on there to keep it warm?
Yes. When you look at the helicopter, right, you have the solar panel on top with the antenna, and then next is the rotor system, and then bottom, what you see, this cube, is what we call the fuselage. You are seeing it now actually uncovered because you're seeing the last day of final, we're recovering, for delivery to be integrated onto the rover. Okay, so usually you won't be seeing that. So the center of the cube is the ring of batteries. Okay, there is space between the battery and the circuit boards that you're seeing, and then there will be a shell that we put on called the fuselage shell, and that will close like CO2, the gas around, and so the enclosure itself, we're using the CO2 gas as the insulation material.
Oh wow, no aerogel.
No aerogel. We did consider it was in the game. It was in the consideration in the beginning, and it turns out that just the CO2 as insulator itself was sufficient for us to close our thermal model.
Right.
And so, guess why we wouldn't want to use aerogel if we have a choice?
Wait.
There you go. You're welcome to our team.
Now, before the helicopter can experience the frigid conditions on Mars, first it has to get there. And that's a reminder that not only is this an aircraft, it's also a spacecraft.
It has to survive launch. It has to survive launch loads, which, easily exceed about 80 G. Because of the vibrational loads are 80 G.
Yeah. Then it has to survive the 7-month trip, complete with radiation. And finally, after pulling 9 Gs on entry into the Martian atmosphere, the helicopter needs to be deployed. This is going to be on the rover. Before you take off, does the rover pick you up and put you down somewhere?
We're going to be stowed underneath the rover on the belly pan on our side. And there's going to be several sequences of firings of explosive devices to actually rotate us right side up and then drop us on the surface.
For example, the very last thing that the rover does is it's got us by this bolt and it's holding us, about this high, and then it has to drop us, right?
Yeah.
So how do you undo a bolt on a spacecraft?
Just blow it up.
You blow it up. Basically, it's the materials, undergoes a phase transition, which certainly increases the stress in the metal part of the thing and makes the bolt break. It's called a frangibolt.
Then once we're on the surface, the rover drives over us. It gets about 100 meters away, and then we have about a 2-hour counter internally where we'll wake up after 2 hours, wait to hear some RF transmissions, and if we do get that link with the rover, then great.
Our base station on the rover would issue the fly now command. First flight will probably be a mutual selfie, you would think. This is, after all, the selfie age. So
I like that as the goal of the first flight.
Yes, it is. In fact, the best time to fly this is at 11 o'clock in the morning local time on Mars. And the reason for that is we would have come out of the night where we would have spent a lot of battery power trying to stay warm. By 11 o'clock, the state of charge would have gotten to the point where we could fly without risking brownout on the battery and then dropping the whole craft to the ground. Also, 11 o'clock is where the sun would have warmed up things, so we don't quite have to heat up as much. And also, it's not late afternoon where, because of the warmth, the density has begun to drop, okay, and the winds have begun to pick up. Now, What we will investigate is after we get the first couple of flights under our belt, I'm sure we will try to fly in the afternoon and do more exploratory things. But the most conservative thing we can do is to sort of pick a mid-morning flight.
So what is the purpose of this mission? The Mars helicopter is first and foremost a technology demonstration to prove that we can fly on another planet. The helicopter can take color photos and videos, but its purpose is not to make scientific discoveries. Instead, it is to help engineers figure out how to design and build aircraft for future missions.
You can imagine something that's about 30 kilograms carrying, a 2-kilogram science payload, doing exploration, acting like a scout, like a small vehicle like this, scouting ahead for some future rover. Or it could be a gadget that goes and picks up some kind of samples and brings it back to a central lander for more sophisticated analysis. Or it could be a completely standalone craft, and maybe more than one, that are exploring places where humans and rovers can't get to easily. So polar ice scarps, sides of cliffs and so forth. So the real emphasis here is to try to get back all the engineering data so that it can inform that future design.
Flying on other planets will provide a new dimension in space exploration. An aircraft is faster and capable of covering more ground than a rover, and it can provide higher resolution imagery than an orbiting spacecraft. So maybe one day aircraft will be the companions of future rovers or even astronauts exploring other worlds.
Very nice.
Well,
Oh, yeah, Marcus. Okay.
yeah, this is the next video, but that was pretty good, and I do need to give a shout out to Veritasium, and it's got about 6.8 million subscribers. So it's a very popular show, that one. And yeah. So does anyone want to?
Veritasium, and the guy who runs it used to be at the University of Sydney.
Used to be a which? Sorry.
At the University of Sydney.
Oh, okay. Well, they've produced a couple of good ones, and that was brilliant. So, do we want to have a question and answer, or do we just want to go to the next video?
Well, I've got a question. So obviously they were showing in the video there that the thing was taking pictures. So one assumes there is a camera on board the helicopter.
Yeah. So they use ground terrain to measure their position and location. The Lunar Reconnaissance Orbiter has taken some very, very high resolution pictures, and they've digitized those. And both the rover and obviously the helicopter has stored that in its brain. So they will be looking to accurately land the rover. It's a pretty wild terrain, apparently, where they're going into the crater. It was an old river delta because, as you know, the rover's looking for life. I mean, this one is there to look for old fossils or maybe living life. So
what are the sensors on the helicopter does it have other than the camera? Like it'll look at somewhere that looks good to land, and then what will it? It
doesn't do much because, as the guy said, this is experimental.
Technology.
This is really, test of concept to see if they can do something useful on Mars. So it'll be a pretty cool mission. Actually figured out in that video how the thing is going to land. What they do is they obviously land, they fire the bolts just before it gets to the ground. It orientates itself. Then as soon as the rover lands on the ground, the helicopter is released underneath it. It must be, a distance between the back pan of the rover and the ground. And then the rover basically drives over it and moves away. And then they're ready to go. So it's clarified how they do that. That's good. Anyone else got any questions? If not, let's go to our local guy, and a shout out to Marcus House. Marcus is he's just getting better and better by the day. He is an Australian space advocate and presenter. I would recommend everyone subscribe to his channel. He's from Tasmania. Lawn System. I forgot how to pronounce it properly. Tina picks me up on that if I don't pronounce it properly. So, but he's very good, and he mainly does SpaceX, but does some other American space program stuff. But this is only days old, and we can get a bit of an update as to where we are with the SpaceX stuff. So here we go.
Apparently, Lawn Session's a place to go for head tattoos if you're interested.
If you're into head tattoos, that's a place to be. All right, moving on. Why? Hang on. I've got to start the video. Sorry, guys. Here we go. And shout out to Marcus. He does a very good job. Here we go.
This video is sponsored by Brilliant. Hey, Marcus House with you here, and another incredible week at Boca Chica with rapid development and stacking of the SN3 Starship. This beast is destined to take at least a short flight very soon, so exciting times here. We had SpaceX's Starlink 5 mission during the week as well, which also had some interesting surprises. Another lost booster, which is quite abnormal these days, so we'll talk a little more about that. Then we had Rocket Lab make some intriguing news of their own with an acquisition and a new certification announcement.
Okay, Neil, we can see you coming down the ladder now.
Over to Boca Chica in Texas to catch up on Starship development. Early in the week, SpaceX shipped the SM2 test tank back to the construction yard. We were thinking this is likely just to clear the space at the launch site in preparation for the next tests to be undertaken. At this point, we are unsure if the SM2 will ever be used for anything else at this point. It may simply be deconstructed now that it's served its purpose. Now, some interesting information from Elon this week. When asked about the plans for material that will be used on future versions of Starship, Elon responded saying that some of the parts will use 304L stainless steel as it has a higher toughness at cryogenic temperatures. In the longer term, SpaceX will move to internally developed alloys probably by the end of the year. Now, this is interesting in a number of ways. The 301 stainless steel, which we believe is in use for the majority of the current Starship builds, has lower chromium and nickel content than 304 steel. This actually makes the 304 steel typically a little more expensive. That depends largely on the costs for chromium and nickel at the time, of course, but the 304L variant that Elon mentioned here in this tweet refers to an extra low carbon version of the 304 type. After talking to a few people, it seems that this decision may help in a number of ways. The 304L appears to minimise some common issues with welding. Typical 304 steel tends to corrode easier in comparison to the L type. On the flip side, it does seem quite a bit weaker at room temperature than the...
Uh-oh. This is not looking good. Hang on.
Please do let us know your thoughts in the description about all this. It also looks like SpaceX are having some good success with the Raptor engines. Elon said this week that there are lots of Raptors coming through and operating on both horizontal...
No, I'm struggling here. I think the computer's not doing too well.
Is this downloaded video or live streamed?
Having some good success with the Raptor engines. Elon said this week that there are lots of Raptors coming through and operating on both horizontal...
No, this is downloaded video.
Oh. Weird.
Yeah. I can hear my computer struggling.
Well, your image and audio is perfectly smooth and clear.
Yeah, we can see you fine.
Let me just bear with me for a sec. I'll fire it up again. My computer sounded like that Martian helicopter. So what I'm going to try to do is try to do it again. right. Let's try again. Hold it, guys.
Ian, how are you, Ian?
Yeah, and unmute. Oh, I've lost my picture.
Through and operating on both horizontal, but the entire.
I'm trying to figure out why this is. Why is this so? All right.
What player are you using?
I'll tell you what I'm going to do. Plan B. Bear with me. Just bear with me, guys. I'll be there in a sec. All right. Marcus House. Here we go.
Just keep working in the lab. You'll be right.
Sorry?
Just keep working in the lab.
What are you developing, a anti-coronavirus thing or something there?
I think it'd be dead if it was in there.
You know what it is? Believe it or not, it's a corrupt video.
Oh, let's see it.
It's a corrupt video, which means I might try...
Not that sort of corrupt.
I might try going to YouTube. Just bear with me, guys. I'll get it straight off YouTube and run it straight
You mean
off.
you didn't test your videos prior to the show?
I didn't watch all 15 minutes, if that's what you're saying.
Traps for young players, I tell you.
Oh, I tell you what. Should have been right onto that one. Okay. I'll have this up and running in a sec. Just bear with me. Okay, now, just bear with me. I'll now kick it off again.
Good for another 40 minutes.
Here we go. Bear with me. Here we go. That's what I'm going to fire up. Share. See if this works.
This beast is destined to. It has a higher toughness at cryogenic temperatures.
Now, where did we get to?
Some common issues with welding. Typical 304
steel
tends to corrode easier in comparison to the L type. On the flip side, it does seem quite a bit weaker at room temperature than the 301 steel, which is likely why Elon is saying here that some parts will use 304L. Now, I'm certainly no expert in this area. If you are, please do let us know your thoughts in the description about all this. It also looks like SpaceX are having some good success with the Raptor engines. Elon said this week that there are lots of Raptors coming through and operating on both horizontal and vertical firing stands. Of course, this engine, for those that don't know, is a full flow stage combustion engine fueled with liquid methane and liquid oxygen. Not only that, but this was also the first engine of this type to ever fly, first with the Starhopper flight last year, and we are hopefully going to see 3 more of these firing up together to do short flights with this SN3 Starship very soon. If you are interested in more information into why this engine is groundbreaking, I've got a link popping up here in the top right. I love the beautiful exhaust from the engine. The Starhopper 150-meter test flight really shows this beautifully. It's just so clean compared to the typical RP1 that we're used to seeing with the Falcon 9. Another interesting conversation here between Raphael and Elon Musk. After wanting a little clarification in the Starship length based on recent discussions, Elon responded saying that 20 meters is close and the design is evolving rapidly. It would be great to flatten domes, embed the engines and add around 1.5 barrel sections of propellant for the same total length. So yes, they're really here trying to make the whole structure more efficient. The curve in the bulkheads are quite pronounced, and I guess it's quite difficult to make useful space from around these sections. The curve, of course, produces great strength compared to a flatter design. However, something in between would likely offer some space savings while still providing adequate strength. Now, Raphael here put together some great graphics showing estimated volumes for the tanks and fairing. When we compare the usable space inside the main fairing area where the crew and cargo will live, there is significant reduction to space due to those higher domes. Also interesting is the rough volume calculations here appear to come remarkably close to Raptor's expected 1 to 3.6 liquid methane to liquid oxygen ratio. Elon also complained a little about the legs here being too small, and based on what we saw with the Mark 1, I can certainly agree with all that. I've been assuming the legs would end up being quite a lot larger at some point because this here wasn't looking overly realistic. As always, we saw some great video from Boca Chica Gal with NASA spaceflight with the SN3 Starship components coming together this week. The footage of this bulkhead here shows it flipped upside down. This is actually the bottom of the liquid oxygen tank with the latest version of the thrust puck structure incorporated into it. Beautiful shots here as always. If you're not subscribed to the NASA Spaceflight channel, that is a great channel to follow. These video content segments are dropping there almost daily. A link to the channel there is in the description. So yes, the triple ring stack was fit over the bulkhead and work continued heavily on this whole segment of the SN3 for quite some time. This is one of the more intricate components, of course, as these are where all the engines are to be mounted. By midweek we were seeing a lot more stacking going on, this time with the nose cone. We've seen the top half of the nose sitting by without much action for a while, but the entire component was lifted up on top of the newer lower nose cone section here. Over to the assembly building, and there was loads going on here as well. Work continues on the building itself with wall segments being attached throughout the week. There hasn't been a huge focus on this since the main structure was completed, however, it certainly looks like it's going to be finalised very soon. More excitingly though, we spotted this awesome little internal elevator during the week. This is certainly going to help the team move to segments of the Starship as it's being constructed quickly when compared to needing the constant movements of the bucket vehicles to get to common areas of the Starship. The development speed seemed to ramp up even faster at this point, and wow, some of the footage was just mind-blowing. Just take a look at the thrust puck structure here from inside the tank. I don't believe we've seen anything with this clarity before around this area. We can see the main lines that will lead to the future set of 3 Raptor engines. The structure themselves were looking much cleaner when compared to all previous ships to date. Now, as the week progressed, we've seen a bunch of these tank components stacked. This current diagram, also by Raphael, shows us how all the sections around the shipyard here will come together. From the top down we have the nose cone shown earlier. Some other sections are still under construction that make the bottom of the nose cone to the tanks, but these shouldn't be too far away. Then comes the massive tank section itself we see in the assembly building here, making up both the liquid methane and liquid oxygen tanks. Then comes the engine bay with the thrust puck structure underneath, with just a few final rings to go right at the bottom to accommodate the engines and landing legs. Thanks again, Raphael, for sharing these amazing diagrams. I'm just so happy to see that we have this incredible work being filmed by amazing people out there such as Boca Chica Gal. It's a real privilege to even be able to see it all publicly here like we do. This is why SpaceX, and more specifically Starship development, is exciting for so many of us. We can see this design and engineering effort in real time. The fact that you all followed this channel to catch up on this stuff just blows my mind as well. I couldn't do what I'm doing without your support, and with you amazing people out there following me, we can all share in this interest together. Some positive news right now really is what we all need, so thank you for all being engaged with all of this. I don't think it's too much of a stretch to suggest that some of this footage that we're seeing here will end up in history books. Thanks very much, Mary. Awesome work. The thrust puck structure here in some of these shots certainly seems a lot more solid and robust than the version that caused the SN1 Starship to explode. If you want to know more about that incident, I've got a video here that goes deeper into all of that. While you're here, of course, please do consider subscribing. There's loads of news coming, not only with Starship, but Starlink and Crew Dragon. I'd love to share all that with you. Now, Lab Padre, who provides a bunch of live stream footage at Boca Chica, was out making some mad progress with the new site being built up for camera equipment. This is a major upgrade, so it's going to be awesome to check out some new video once the site here is set up and running. A lot of concrete foundation work going on here, of course, so interested in seeing this unfold. It should make for some super material. Obviously, all of this setup has quite a large cost, so if you utilize this service a lot, please do support the channel there to help fund this stuff. Thanks, Lewis, for the dedication to the setup here, mate. What you're doing is most appreciated by all the Starship fans out there. It's also worth noting that a few weeks back he grabbed some interesting aerial footage. These shots are just great and they give you a clearer idea of the layout and the magnitude of what is going on here at the site. This shot is a few weeks old now and it gives you a good idea how much larger the assembly building is compared to other structures on the site. It's actually quite a lot bigger than it appears. A huge thank you to Lab Padre for the amazing work being done here to continue providing amazing content for the community. I highly recommend subscribing to Lab Padre's channel if you want to check out the goings on at Boca Chica in real time. A link to that is also in the description. Now, SpaceX's Starlink 5 launch has been an interesting one. We're so used to seeing SpaceX launch so routinely without incident that when things go a little wrong, it seems quite out of the ordinary. We'll talk more of that in a moment, but real quick, this video is sponsored by Brilliant, who have been huge supporters of my channel. Brilliant's mission is to help people achieve their learning goals, so whether you're a student, a professional brushing up on learning cutting-edge topics, or someone who just wants to understand the world better, you should check out Brilliant. Set a goal to improve yourself and then work at that goal a little bit every day. Brilliant makes that easy with interactive explorations and a mobile app that you can use on the go. If you're naturally curious, want to build your problem-solving skills, or need to develop confidence in your analytical abilities, then get Brilliant Premium to learn something new every day. Brilliant's thought-provoking math, science, and computer science content helps guide you to mastery by taking complex concepts and breaking them into bite-sized, understandable chunks. You'll start by having fun with their interactive explorations, and over time you'll be amazed at what you can accomplish. Thank you very much to Brilliant for their support in this channel, and if you would like to help support me and would like to give it a try, go to brilliant.org/MarcusHouse. The first 200 people will get 20% off for the first year of Brilliant Premium. The link is in the description below. So yes, on March 15th, SpaceX attempted the launch of the Starlink 5 mission, but just as the timer hit 0, where we would usually see the Falcon 9 take to the skies, this time the rocket made the decision to abort. We all witnessed the engine plume followed by a quick halt before the engines fired up to full power. SpaceX later tweeted that this was due to out-of-family data. This means that the full family of 9 Merlin engines did not fully power up as expected, which triggered the automated abort. A few days later though, the mission did launch, and this was the 5th flight of the booster. Reusability is a core of everything that SpaceX does, so this was an exciting one to watch. There were some bonus snapshots of Starship development included in the introduction of the live stream as well. A bunch of bulkhead shots here, but one that was particularly interesting for me were the shots of the Starship section here that surrounds the engine section at the bottom of the Starship. Nice to see such detailed shots of the welding work here. So yes, this Starlink mission was flown with the booster designated B1048, and it had already flown 4 other times. Sadly, that was its last flight because we didn't even hear a call out for a landing burn at all. As far as we've seen, the booster was lost somewhere between re-entry and that landing burn. Elon Musk quickly provided an official answer on this, saying that there was an early engine shutdown on the ascent, but it didn't affect the orbital insertion of the payload. This demonstrates the value of having 9 separate engines. Even after a failure, the mission could proceed as normal to get that payload into orbit. He also added that a thorough investigation will be needed before the next mission. So yes, this is the 2nd loss in a row from a drone ship landing, which were both coincidentally Starlink launches. The CRS-20 mission in between, of course, landed back at the landing site. The fairing recovery ships Go Miss Tree and Go Miss Chief were out there to attempt another catch of both fairings. SpaceX tweeted soon after saying that after landing in the water, both fairing halves were quickly recovered. So yes, sadly no catch out of the air for this mission either. Simply dragging them in from the ocean is still effective though. The only reason it's more ideal to catch them out of the air is just to limit saltwater damage to the internal components of the fairings themselves. These fairings in particular had flown before on the Starlink mission from May in 2019. It's great news to see the fairing reusability making some progress there. Although it's only the second time SpaceX has reflown a full payload fairing, we certainly expect to see many more. So yes, regardless of the loss of the booster, the Starlink mission was a complete success, and just before deployment it was announced that the previous test paint that had been used to reduce reflectivity of the Starlink satellites has shown a notable reduction in the amount of light reflected to the ground. This whole subject, of course, has caused a number of those in the community to be quite upset about the proposed Starlink network, claiming that it will ruin astronomy. More interesting, though, was the idea mentioned here in the live stream, saying that a sunshade is a promising solution which would deploy to assist in this issue. That's an idea planned for a future launch. This is quite interesting. I can't wait to see how that would work. Another 60 satellites in orbit, and we're getting closer and closer to a network that can be utilised. I just love watching the full stack of satellites here just drift slowly away. Incredible footage there from SpaceX, as always. Now, if you are a fan of the incredible work Rocket Lab have been doing in the small satellite arena, you might be interested in this news here early in the week. Rocket Lab will acquire the satellite hardware manufacturer Sinclair Interplanetary, which is going to allow both companies to join forces and improve the capability to provide small satellite customers with better launch services. Sinclair Interplanetary in the past have very successfully developed components such as reaction wheels and star trackers that support the small satellite vehicles. They have, of course, also worked tightly with Rocket Lab on missions before, such as the satellite by Astro Digital, which launched back in October of 2019 on the As the Crow Flies launch. This is all great news and means that Rocket Lab and Sinclair as a combined team can kick some new goals together. The details haven't been fully disclosed, but I'm excited to see progress with the production of the Photon spacecraft, which is a key reason for this acquisition. This section of the rocket is the final stage, and it's essentially an evolution of Rocket Lab's kick stage. As they say on the website, the Photon spacecraft is a high-powered iteration of the flight-proven 3D printed Curie propulsion system, and it can support mission lengths as high as 5 years. So yes, it's always exciting to see news here with Rocket Lab. Even though these are small satellite launches, the technology in this arena is super important for the many customers that can't be delivered to the orbit they need on a shared mission, such as what we sometimes see with SpaceX Falcon 9 shared launches. Now, along with this, Rocket Lab has also announced that NASA has certified the Electron rocket, which provides new confidence for future low-cost small satellite missions with NASA. This has all been made possible by the previous missions, such as the successful launch of NASA's ELENA 19 mission, which placed 13 CubeSats into orbit in December of 2018. Congratulations, Rocket Lab, for these amazing achievements. We can't wait to see some new launches very soon. Now, just quickly, a huge thank you to my amazing patrons here. You are quite literally turning this dream of mine of creating this content from a hobby into something much bigger. If you like what I do and you would like to join our awesome patrons here, head to patreon.com/MarcusHouse. You can interact with me more directly via the included exclusive roles in Discord. You can check out some exclusive patronating content, and you can have your name listed right here like these other incredible people. A massive thank you, of course, as well to my quality control squad here for helping me research and proof the material for these videos. If you're interested in these topics and would like to be part of this, follow me on Twitter and please do get in touch. In the tile in the bottom left today, we have my video from last week talking about the Starship development and all sorts of other news. In the top right is my latest video, and in the bottom right, content that YouTube has selected from my channel just for you. Thank you everyone for watching, and we'll see you all in the next video.
Okay. Hope that was interesting.
Yeah, really good.
It was, yeah, and we did talk about, you know, should we stop the ads and the promotion and whatever, but reality is that if we're showing his material, we should be, you know, watching the whole thing. So,
yeah, no problem.
If it takes, you know, if we want to promote him, because the more he does, the more information we get. All right. Now, the next thing is we'll go back to our PowerPoint. Does anyone have any questions? Oh, yeah, I've got to share again. No questions? All right, let's go back to PowerPoint and let's see where this takes us. Okay. This guy is good too, and this is a good Okay, can everyone see that?
Yep.
This is a guy I need more space. He's TJ Cooney. I haven't figured out what TJ is yet, but he did a really good presentation on SpaceX versus Blue Origin. They both have very different philosophies. As you can see, Elon Musk builds his rockets in a shipyard, as he calls it, and he builds it outside, whilst Jeff Bezos for Blue Origin is very controlled, typical aerospace type company, quality assurance. So we need to see what the differences are. So here we go.
SpaceX is the most well-known name in the private spaceflight industry and needs little introduction. It was founded by dot-com billionaire Elon Musk in 2002 with the goal of making humanity multiplanetary. They've repeatedly made ambitious development claims and stunned the world by delivering upon them. 2 years before that, however, in the year 2000, Jeff Bezos founded a private spaceflight company called Blue Origin with the goal of enabling millions of people to live and work in space. The technologies being developed by these companies seem to largely overlap, but they are just very similar answers to two very different questions. Today, we'll be looking at these differences in their approach to spaceflight. Hi everyone, TJ here for I Need More Space. In each episode of this series, I'm going to take two components of spaceflight and compare them to one another. Hopefully, we both learn how they came to be and get a better understanding of the story of space's past and future. In this video, we're going to cover the origins and motivations between both SpaceX and Blue Origin. Let's jump in.
7, 6, 5,
First stage
4,
engine sequence initiated.
3.
On the 20th of September 2008, SpaceX's Falcon 1 became the first privately developed liquid-fueled launch vehicle to reach orbit on its fourth launch attempt. Blue Origin, almost a decade later, still hasn't gotten there, and this draws them a lot of criticism from the spaceflight community. It makes absolutely no sense at first glance. Between 2002 and 2019, SpaceX has developed a small-sat launcher, developed an orbital workhorse rocket while also being one of the cheapest launchers on the market, vertically landed the boosters of said rocket, reflown them multiple times, and dropped its launch cost even further. They developed a cargo resupply spacecraft for the ISS and a crewed variant for orbital spaceflight, developed the largest rocket currently operational and shot it into heliocentric orbit, still not over that, developed the world's first full-flow staged combustion engine for their fully reusable interplanetary spaceship capable of carrying 100 tons to the Martian surface and crews of up to 100 people. Meanwhile, Blue Origin has only managed to fly, propulsively land, and refly a suborbital booster capsule system called New Shepard for space tourists. However, they have nearly finished development on a massive semi-reusable orbital launch vehicle called New Glenn, which absolutely dwarfs their first rocket. Designed a lunar lander called Blue Moon, planned a biconic crew capsule, which they proposed for commercial crew phase 1, and possibly even a space plane called the New Lindbergh in the far future. So what's going on here? Why has SpaceX seemed to make so much more progress than Blue? They both hire from the same talent pool of incredibly talented aerospace engineers, and they even poach them from one another. So it makes no sense for them to have barely anything to show for it. Well, it's intentional. Blue Origin's design philosophy has been gratuitum ferocitor, or step-by-step ferociously. SpaceX sprints through their development, constantly tweaking their designs to the extent that no two Falcon 9 cores are identical. They always have some new hardware being tested. Developing an orbital-class rocket engine is one of the hardest engineering challenges known to our species. It is incredibly resource-intensive, requires a ton of auxiliary infrastructure such as test stands, and has no guarantee of success because of the unique ways in which it pushes mechanics, thermodynamics, and material sciences into their physical limits. SpaceX has had a very hard time funding and developing their Merlin engine by themselves. Developing it from scratch was near impossible. But SpaceX does the impossible all the time. So they adapted NASA's Fast Track engine, originally developed for the reusable X-34 spaceplane, into the Merlin 1A. This engine was very different from the Merlin 1D that flies on the Falcon 9 Block 5 today. SpaceX didn't even build the turbo pump assembly for it. Instead, it was outsourced to one of the original developers of the Fast Track, Barbara Nichols. Over the next few years, SpaceX developed the Merlin with incredible testing regimen. They would fire the engine at the McGregor facility with new optimizations until something broke, failed, melted, or cracked. Then they would relay the data to Hawthorne, order the fixes and replacements, and torture it on their test stands again. This has turned their Merlin into one of the best Curolox engines in existence. It has the highest thrust-to-weight ratio of any liquid rocket engine. Also, being able to relight, survive supersonic reentry, and land the Falcon 9 boosters with consistent precision. Because of the same development, the Falcon 9's payload capacity more than doubled from 10.4 megatons on the first version to 22.8 megatons on the Block 5. They are very reliable, and there's just one incident of them shutting down in flight on the Commercial Resupply 1 mission, which still completed successfully. All of this on an engine that they had not designed themselves. This represents the best of SpaceX, and the reason for their absolute superiority in the launch industry. They took the engine they could afford to develop and honed it into becoming one of the best in the industry. The same engine powered trailblazing Falcon 1, their workhorse for the Falcon 9 and the colossal Falcon Heavy. This earned them the CRS contracts from NASA, which were essential to SpaceX's survival in its early days. It brought on their most important clients, Iridium, SES, NROL, foreign governments, and private satellites. This provided them with the capital they needed to survive and continue developing towards their goal of interplanetary spaceflight. Blue, on the other hand, believes that slow is smooth and smooth is fast. They take large, calculated development steps, 3 at a time. The design choices they make are deliberate and strategic. Consider the New Shepard. It is a suborbital booster that carries crew and lands vertically. It uses hydrogen as its main propellant. This sounds like an absolutely awful decision at first glance. Hydrogen is very difficult to work with. Its only advantage is that it has the highest vacuum efficiency of any liquid propellant, which is wasted as its entire launch profile is within the Earth's atmosphere. Hydrogen has a tendency to leak through the tank walls of the booster because of its smaller atomic size and light the exterior on fire, which makes it unsuitable for carrying crew. Hydrolox engines are heavier than most and hence have poor thrust-to-weight ratio, a factor which is very important for vertical propulsive landings. Hydrolox is more difficult to throttle because of its lower density, which also makes landing it harder. So why would Blue pick Hydrolox out of all the propellant options? Well, because you can make it out of lunar ice deposits via in-situ resource utilization. Wait, what? The New Shepard can't even get to lower Earth orbit by itself. What does the moon have anything to do with it? Okay, let's look at the New Shepard booster. Now imagine that the LH2 tank gets replaced by a massive spherical one, and the liquid oxygen tanks get split into 2 attached around the sides. Isn't that basically the Blue Moon lander with a crew descent stage on top? Blue Origin built the technologies they required for their lunar lander while also developing a space tourism vehicle that will generate revenue. The engine they developed for this vehicle will be reused as the super efficient second stage engines for New Glenn. It's honestly a genius move. Blue Origin has also built some very strategic partnerships, both in the industry and politically. While SpaceX prefers tight vertical integration and developing everything in-house, Blue Origin is willing to collaborate with legacy industry. Blue's BE-4 engine will be the main engine on United Launch Alliance's next-generation Vulcan rocket. The Blue Moon lander can be launched with a variety of rockets apart from New Glenn, including the Space Launch System, Vulcan, or Atlas V. When NASA solicited a crew lunar lander for Artemis, they quickly partnered with Lockheed Martin, Northrop Grumman, and Draper to make a very strong bid. They also worked with Maxar on the Gateway's power and propulsion element. And interestingly, Blue's low Earth orbit space station concept showed a very similar module on top, suggesting further collaboration. While SpaceX picked the locations of the manufacturing at Hawthorne, testing at McGregor, Texas, and launch sites at the Cape based on feasibility, affordability, and convenience, Blue's recent moves have been more politically motivated. They have their HQ in Kent, a suburb of Seattle, which is home to Amazon, and they fly New Shepard from West Texas. But now here's the interesting part. They picked Cape Canaveral to manufacture their New Glenn rockets and leverage Florida's Space Coast subsidies. They are also building an engine production facility in Huntsville, Alabama, which is politically significant for spaceflight policy. It is home of United Launch Alliance's manufacturing facility and NASA Marshall Space Flight Center, where they will test their engines for both the New Glenn and Vulcan. This represents the core distinction between SpaceX and Blue Origin, and it is a product of their upbringing. See, when Elon founded SpaceX, it nearly used up all the capital he had. SpaceX had to scramble to get customers and contracts if they were going to survive, let alone develop anything else. This turned them into an incredibly agile and efficient company that iterates their designs as well as their plans constantly. This is clearly indicated by Starship's development process, which has fundamentally changed the design in every possible way, while still being true to its purpose. A fully reusable super heavy lift launch vehicle capable of taking crew and cargo to the Martian surface. Blue, on the other hand, has had no such constraints. Bezos graciously sells $1 billion of his Amazon stock and leaves a neat pile of cash at the factory's doorstep every year. Stable funding is guaranteed and no one's in a hurry to grab contracts. They can take their time to build incredibly robust system infrastructures and will support their plans for decades. It is the reason why their first orbital rocket isn't a small-sat launcher, but a behemoth with a 7-meter core and height comparable to the Saturn V. Oh, and Bezos casually mentioned that this is the smallest orbital launch vehicle they'll ever build. So now we can clearly see why SpaceX and Blue Origin take their respective approaches. But what are they doing it for? Why do they choose to go to space? Why does Kent play Hawthorne?
Why does Rice play Texas?
That's my terrible JFK impression, sorry. SpaceX has a very clear goal: to make humans multi-planetary. We are the only sentient life form we are aware of, stuck here on the pale blue dot. Over the past century, humanity has grown to a scale where our individual actions have measurable effects on the entire planet. Climate change, nukes, bioweapons, AI, who knows? This is an existential risk, and the probability of our extinction will be much lower if we can have self-sustaining civilizations on multiple planets in the solar system. Elon believes that it is uncertain how long the window to achieve this would be open. Therefore, we must do our best to establish a backup civilization on another planet, the only feasible option being Mars. The minimum number of resources required for a self-sustaining civilization on Mars works out to be about 1 million people, along with a massive amount of cargo, raw materials, structures, supplies, and equipment manufactured on Earth. To accomplish this with traditional rockets simply isn't possible, which is why SpaceX is focused on developing Starship to transport 100 Mars settlers at a time, along with supplementary cargo missions. Blue Origin has different plans and motivations. They stress on the fact that this planet is irreplaceable. No other place in the solar system can provide a better place to sustain life than Earth itself. However, they do acknowledge that it is finite. We are reaching the limits of the material and energy resources, and damaging this planet in the process. Blue Origin's solution involves moving heavy industry into space and turning Earth into sort of a national park for humans and the rest of the biodiversity. It is also essential that humanity keeps growing. In the far future, even the Earth as a whole cannot support a population of trillions of people. This is where Jeff Bezos' grandest vision comes into the picture: enabling O'Neill colonies. O'Neill is known for questioning why humans must live on planetary surfaces in the first place, and for his designs of massive rotating cities in their orbits. This has a vast amount of advantages and is a much broader topic for another time. Bezos was absolutely fascinated by the idea, and even discussed it in his graduation speech. Jeff Bezos acknowledges that the gargantuan rotating space cities won't happen in his lifetime. Instead, he hopes to create the infrastructure it would require for future generations of entrepreneurs to make this a reality. He likens it to the internet, the postal delivery network and banking system that he was able to build Amazon upon, and would like to solve some of the barriers to spaceflight access so that the humans of the future can develop the new frontier. This involves reducing the cost of launch, making the use of asteroid resources feasible, and accessing the lunar ice deposits to fuel a colossal cislunar economy capable of bringing such visions to reality. So, we have spent this video establishing the differences between Blue Origin and SpaceX. Let's leave it off on a note about something they share: a firm belief that humanity isn't confined to this planet. They are both committing the drive, resources, and talent we require to solve the major barriers to spaceflight access. These companies are at the forefront of a new wave of private spaceflight, and they are taking some very interesting approaches to it. So, Who do you think has a better vision for the future of human space settlement? Is it SpaceX's Mars habitats, terraforming multi-planetary spaceships, or Blue Origin's visions of preserving Earth as a natural park by moving factories into space and building sprawling space cities from off-world resources? Let me know in the poll above. Let's have a discussion in the comments section about other distinctions and the approaches taken by Blue and SpaceX. What did I miss? Also, I just want to really do a quick tease that I have started a store, ineedmore.space/shop or /store, both work. I got some shirts on here and just some cool designs I think you guys would really enjoy. So thanks for watching. Hope you follow me on social media. I'm at TJ_Cooney on Twitter. I just post random photos and videos about spaceflight and the history of spaceflight I find interesting. Just really hope you consider subscribing and join me on this adventure.
Shilito, he is curious droid. He does some really good stuff. And again, all the people I've shown tonight, get on board, because the more people they get, the more information they can put on the net. Now, this guy is pretty good. His topic is how we plan to go to Mars by 1982, the early manned missions. So this is quite good as well. So here we go.
With all the talk of manned Mars missions by Elon Musk and SpaceX, and more recently NASA, it's easy to forget that Mars isn't a recent obsession. Now, before we get into the details, this video is a little different because this is my first collaboration, and part 2 of this series will be done by Isaac Arthur, who will be looking at the Mars missions from the roots of sci-fi in the 1990s to those which are proposed for the coming decades. There's a link in the description that will take you there directly, and if you've come over from Isaac's channel, welcome to Curious Droid, and the first part of the manned Mars missions that were planned for the post-Apollo period but never got off the ground. And I hope you can take a little time to have a look around this channel and also at some of the other videos, and hopefully like and subscribe. Now, if you haven't heard or seen Isaac's channel, then I recommend you hop on over there after you've watched this, of course, because this is a kind of setup for his video. But his channel deals with the science.
Sorry, who's got the background kids yelling and screaming?
I think it might be Mark.
Who is it?
I think it might be Mark. Isn't it going on? The highlight? Yep.
No, they've got muted. Ashley, everyone's muted.
Yeah, he only just muted and the noise stopped, so it must have been him.
All right, let's continue.
And futurism, and covers a whole load of things that I've never even thought of, but I found highly informative and very entertaining. Well worth a visit if you like your futurism on the grand scale. Ever since Konstantin Tsiolkovsky, Robert Goddard, Hermann Oberth and Robert Esténard-Pelterie discovered the principles of rocketry and astronautics in the early 20th century, we've been planning on going to Mars, though back then it was much more of an academic issue with a large dose of science fiction. But with the development of a V-2 rocket led by Wernher von Braun whilst he was working for the Germans in the 1940s, the possibility of space travel became a reality. By 1948, when von Braun was working for the US developing its rocket capability, he'd published a book called The Mars Project. This has become probably the most influential book on the subject of manned Mars missions, even though it was a rather grandiose scheme which called for a fleet of 10 spacecraft carrying 70 or more people. Von Braun used the idea that if Columbus had set off to find the New World with just a single ship, then he would probably have never made it back to Spain. Although his book was looked upon as sci-fi by some, von Braun provided detailed calculations to support his theories, and many of the ideas he put forward, like reusable shuttles, orbital assembly and multiple spacecraft, have greatly influenced NASA's long-term plans for manned interplanetary missions, even if they have been greatly cut down in scale. He also covered the main problems of getting men to Mars, such as the effect of weightlessness on the human body, radiation from the sun and cosmic rays, using spacesuits to move from one ship to another if one were to be disabled, and also the psychological effects of having people live in an enclosed space for long periods of time. Back in the 1950s and 60s, there was still the belief that if you're going to go and do a space mission, then you go big. Just like Apollo was a huge effort employing around 400,000 people, the Mars proposals from both the US and the Soviets were equally large, especially when national pride was at stake and the spin-off was a range of new advanced weapons. In the Soviet Union, their answer to the Saturn V, the ill-fated N-1 rocket, had actually been designed by Sergei Korolev in the 1950s to launch a manned Mars mission. The first serious Mars planning done by the Soviets was headed by Mikhail Tikhonravov in 1956 and was known as the MPK, or the Martian Piloted Complex. This would have a crew on a 30-month mission to land on the Martian surface and stay there for just over a year before returning. There were even plans for a nuclear-powered Mars train to be made up of 5 modules which would travel across the Martian surface. By 1959, a group within the OKB-1 Design Bureau had started development of an interplanetary spacecraft called the TMK, which was to carry a 3-man crew for a Mars flyby and drop remote-controlled landers to the surface. A launch date was penciled in for June 8, 1971, and returning to Earth just over 3 years later. To overcome the effects of weightlessness, it was proposed that the TMK would rotate about its axis to create a form of artificial gravity, a bit like the space station in the film 2001. However, because of its small diameter, the Coriolis forces created could have induced nausea, which would have been worse than the weightlessness itself. Radiation was still an unknown quantity, but with data from unmanned probes, it was thought that the cumulative radiation dose for a return mission to Mars would have been within safe levels, but that didn't account for solar flares. This was to be addressed by having a radiation shelter, which was a shielded tube in the centre of the craft with simplified instruments and controls. Even as far back as the 1950s, it was realised that chemical rockets were just on the verge of feasibility when trying to get a manned mission to Mars and back again, and that nuclear, on the other hand, would provide greater power with much lower mass, making for significantly shorter transit times and the secondary ability to generate electrical power once at Mars. In 1954, Ernst Stollinger, who was working on von Braun's team, became interested in electrical propulsion after reviewing a paper on the subject by Hermann J. Oberth. Stollinger believed that a spacecraft could be designed that would give greater thrust than a chemical rocket if it set off from orbit. The nuclear electric engine became the interplanetary propulsion system favoured by the Soviet chief designer Sergei Korolev, basically a nuclear reactor creating electricity to drive a plasma ion thruster. By 1962 in the US, NASA commissioned the Project Empire studies to look into the human exploration of Mars and what would be required. 3 companies were involved: Ford's Aeronautic Division, General Dynamics and Lockheed Missiles and Space. Ford suggested a dual flyby of both Venus and then onto Mars by launching and arriving relative to Mars at the midpoint of the interplanetary trajectory, a sort of planetary double whammy. They suggested using either the Saturn V, Nova or Supernova rockets to launch into orbit, and then the nuclear injection stage and chemical rocket manoeuvring. The whole mission would last around 21 months and cost $12.6 billion, around about $100 billion in today's money, plus the cost of launch vehicle development. General Dynamics suggested just a Mars mission with a crew of around about 8, and again using the Saturn V and Nerva nuclear engine option. They said that with nuclear engines and an optimal launch date of 1973 to 75, when Mars would be at its closest approach, the whole mission could be reduced to 400 to 450 days, including a 30 to 50-day stay in the Martian orbit, with a possible landing and sample return. The team said that it would require 8 Saturn Vs to assemble the Mars mission vehicle and would have a payload around 400 tons. Their proposal would be over a 10-year period from 1965 to 1975 and cost $24.5 billion, $196 billion in today's money. Lockheed's proposal was for a mission to Mars that would last 670 days for up to a crew of 12 and would be a precursor to later missions that would land on the Martian surface. Again, it would use the Saturn V nuclear Nerva propulsion combination. But one interesting difference here was that the team suggested that a craft rotating at 3 revolutions per minute could generate 0.4 g of gravity during the interplanetary phase to help offset the effect of weightlessness, pretty much like the TMK in the Russian solution. Although none of the Empire missions moved beyond the initial design phase, it was the first time since the Mars project that detailed proposals were carried out and shared with the rest of the space community. This in time would convince many in NASA that manned missions to Mars were feasible. By 1969, von Braun had been refining his own ideas for Mars. His final plans had 2 ships, each with a 6-man crew, and would fly in a convoy, with the entire setup, apart from the Mars lander, being able to be reusable for future missions. After the first moon landings, there was a brief enthusiasm for more manned spaceflight. Von Braun proposed his vision of a manned Mars mission as part of a post-Apollo integrated plan, which included a manned shuttle in its original form by 1975, space stations thereafter, plus continued development of the Saturn V as the launch stage, and the Nerva nuclear thermal upper stage for the interplanetary part of the journey. The beauty of this setup was that the proven space station modules would be used as the living quarters for the Mars missions. The Saturn V was by now a well-proven way to get the main parts into orbit, and the Nerva nuclear engine had been tested and was ready to be put into space. The only new hardware required would be the Mars lander. Testing was envisaged starting in 1978 with the first Mars mission in 1982. The shuttle would be used to refurbish the Mars craft in space, with further missions planned for 1983, 86 and 88, with a 50-person Mars base by 1989. However, as we know, things didn't go according to plan. There was resistance from senior figures within NASA to manned missions beyond the moon. By the early 1970s, the public's interest in space had waned. The war in Vietnam was like a political albatross around the neck of the US government and was costing a fortune. There was little public appetite for more hugely expensive space missions. Studies put the cost of a Mars mission at between 12 and 32 billion, or between 93 and 250 billion in today's money. Mars was seen as a dead and pretty uninteresting place, which was confirmed rather ironically by the Mariner 7 flyby the day after von Braun's big 1969 Mars presentation to NASA. With the change of administration in 1972, and even with Vice President Spiro Agnew's endorsement of a Mars mission, Nixon slashed NASA's budget, and the only thing left of the post-Apollo plan was the much repurposed space shuttle and the leftover Saturn V rockets, which were used for the Skylab space station. The Nerva nuclear engine, which was so reliant upon the post-Apollo plan, was also scrapped. In the Soviet Union, the failure to produce a workable N-1 rocket, and with similar economic issues to the US, the Soviet Mars projects were also shelved indefinitely. With the development of the N-1's replacement, the giant Energia rocket, in the mid-1970s and 80s, and the Soviet space shuttle Buran, there was a brief flurry of interest in Mars missions once more. But after the collapse of the Soviet Union, both the Energia rocket and the remaining ideas for Mars missions were also shelved. Although there were successful robotic missions to Mars in the following decades, interest in manned missions in the 1980s and 90s was limited to the die-hard planetary scientists and enthusiasts. Even sci-fi gave up on Mars during this time, as it slipped from much of the public's consciousness, and this is where our part 1 of the story ends, and we hand you over to Isaac's SFIA channel for part 2 of the series. However, we aren't quite done yet. The logistics of planning a mission as complex as sending men to Mars back in the day when most of the working out was done with a slide rule is truly amazing. just like Apollo, it would have been a massive undertaking, bringing together thousands of scientists, engineers, and mathematicians. And it's truly incredible to imagine the full complexity of the operation. To begin to get a grasp of how these things work in the trenches, you might start small. For instance, how fast must we launch an object from the surface of the Earth to get it into space? You can look up the answer if you want, but if you're like me, you want to create things yourself. Our sponsor for this collaboration, Brilliant.org, is dedicated to just that, turning you into a living, breathing, and most importantly, calculating scientist. Head over there and prove for yourself just what it takes to get an object up and off of a planet and headed towards a new home like Mars. Having a strong math and science skill set is crucial because it opens up so many ways to explore the universe. To support Curious Droid and to learn more about Brilliant, go to brilliant.org/Curious Droid and sign up for free. Also, if you're ready to launch off of a planet, the first 200 people will get 20% discount off of the annual premium subscription.
Okay, there you have it. All done.
Very good.
Hope that was interesting.
That was great, Andrew. Thanks for that.
Okay, so we've come to the end. Peter.
No worries.
First off, can I just ask, did those videos come through all right? Yep. Yeah,
they were a little jerky, but it sort of flowed. Like I probably have a little 2-3 stops per second. You know what I mean? Like not 100% smooth, but the audio was crisp and nice.
Okay.
Obviously reduced the frame.
The audio was good. Yeah.
All right. Okay. So
now I don't know whether people want to hang around any longer because it is almost 10 o'clock. Tina Stagg did prepare something which was a tribute to Al Warden. Just goes for a few minutes. Are people wanting to hang around and see that, or do you want to go?
I'm happy to see it.
Yep, me too.
I'm here no matter what.
All right.
Go for it.
You're stuck there. You're a cat.
I wouldn't mind just having a quick three minutes at the end just to show something and just to get a bit of feedback on the whole night, if that's okay. But after Tina's thing.
All right. Play the...
All right. Let's see if I can... I don't know how good my upload speed's going to be because it's not as high as Angelo's, so it's probably not going to be as good. Let's see if this works. Okay, can you see the screen? Yep. Okay, let's see how we go.
Hi everyone, my name's Tina Stagg and I am the entire Tasmania branch of the Space Association of Australia. I'm here tonight to present a tribute to popular Apollo astronaut Al Warden, who passed away last week at the age of 88. He died in his sleep at a Texas convalescent home after a short illness. Social media was flooded with tributes and memories of the popular Apollo 15 command module pilot. Al was born in Jackson, Michigan in 1932 and he graduated from the United States Military Academy at West Point in 1955 and entered the US Air Force. He was a fighter pilot and test pilot before his selection as a NASA astronaut in the 1966 Astronaut Group 5, also known as the Original 19. He flew to the moon with Commander Dave Scott and lunar module pilot Jim Irwin in July of 1971. And during his time alone in lunar orbit, Al controlled powerful cameras and other scientific instruments carried to the moon for the first time on Apollo 15. On the return flight to Earth, Al performed the first deep space EVA to retrieve film cassettes from the scientific instrument bay on the service module. Sadly, the Apollo 15 mission is also remembered for the infamous postal covers scandal, And in the aftermath of that scandal, Al was transferred to NASA's Ames research facility in California. He left NASA in 1975 and went on to a career in the aerospace industry and chaired the Astronaut Scholarship Foundation from 2005 to 2011. Al's autobiography, Falling to Earth, which was written with space historian Francis French, was released in 2011 and became a bestseller. Falling to Earth put responsibility for the postal covers scandal firmly on Dave Scott's shoulders, and it seemed to take a lot of weight off Al's upon the publication of the best-selling book. He spent the final decade of his life enjoying a renaissance of sorts, making rock star appearances at space events, arms in the air, basking in the applause, and enjoying the attentions of whatever pretty ladies might cross his path. Al was, by all accounts, a kind and decent man with a great sense of fun. He had the soul of a poet and penned a book of space-related poetry after returning to Earth from Apollo 15. He loved kids and made 7 appearances on the iconic US children's television show Mr. Rogers' Neighbourhood between 1972 and 1975. He was eager to share the thrill of spaceflight with his young audience. Spacesuit replica maker Ryan Nagata remembered, "He was wonderful with kids and adored my 2 daughters. A devoted father of 2 daughters himself, Al would always make time for the little ones." Another social media post remembered Al's inclusive nature. He never wanted anyone to feel left out and was famous at space events for remembering fans' names. And he would try to make people who were shy or a little bit quiet feel more included by engaging them in conversation, which, you know, you've been to the moon, you don't have to worry about the little people, but that was Al. Al's enthusiasm, energy and zest for life were legendary. And despite his recent illness, his death came as a great shock to the space community, the general consensus being that people decades younger expected to die before Al because they felt that he was so full of life. Falling to Earth co-author Francis French said the final lines of the book were written with the knowledge that Al wouldn't be around forever, and were an epitaph of sorts. So as Francis did in his tribute to Al, I would like to share those last few lines. Sometimes, while I sit and enjoy the good company of my family, the moon will slowly rise above the trees. I generally don't pay it much thought, but occasionally I am reminded of my brief glimpse into infinity while alone on the moon's far side. I still have lingering questions about what I experienced. The answers won't come in my lifetime. That will be your job. Try it sometime. Someday all of us who journeyed to the moon will be gone. Take a walk on a summer night, look up at the moon and think of us. A part of us who's still there and always will be. Vale, Al, and Ad Astra, you will be greatly missed.
Wow, that was beautiful.
So, yeah, Tina recorded that earlier today, and I just wanted to show you that. So,
that was lovely.